Hello and welcome to Elevate 2021. My name is Kevin Ridley, and this session is how to bulletproof your NVO service objects. There's a disclaimer. I'll give a few seconds, but if you need to read the whole thing, feel free to pause. Okay, session agenda. What is an NVO and why do we want to use one? We'll follow that up with NVO best practices. Some of this may be review for some more advanced users. Next, we'll do passing an error string by reference, so we can return both an error code and an error string. The most important part, using try, catch, and finally in your NVO functions. Then we'll go over integrating with logging, followed by our demo, and then a code review, and finally we'll end with Q&A session. Okay, as I said, my name is Kevin Ridley. I am PowerBuilder MVP. Started in 2018 being an MVP, and then again in 2019, and also this year 2021. Over to the left there, you'll see my Facebook profile and also my LinkedIn profile. If you need to reach me at all, you can send me a message on LinkedIn. I check that probably once a week or so, maybe once a month when I'm really busy. So anyway, key skills, in addition to PowerBuilder, actually I've been using PowerBuilder since version 3 and all the way to current 2021. Power Server. Done a few projects with that. Done lots of projects in EA Server way back when, starting in the PowerBuilder 7 days, and then some migrations these days. A lot of people moving off of EA Server or have already moved off. Active Directory, SQL. I pretty much specialize in web services, REST and SOAP, including OAuth and Java and messaging services. Some recent projects. In 2020, I did an integration with PowerBuilder and Power Server with a service called Populi, and using their REST API, and I accessed that with the HTTP client. In 2020, I also did an Active Directory project where we replaced the database user ID and password authentication with Active Directory user ID and password authentication. In 2019, I did an integration with Salesforce. They have a REST API, and connected that with PowerBuilder app using HTTP client and OAuth client. And in 2018, I did very similar with Microsoft Dynamics. They have a REST API as well, and I used HTTP client and OAuth client. About my company name is Omega Solutions, and it is my own company. I do long-term contracts and also some short-term independent project work as well. Okay, enough about me. Let's get this started. NVOs, what are they and why do we want to use them? This slide is geared towards developers with little or no experience with NVOs. So if you're already comfortable working with them, feel free to fast forward to the next slide if you're watching a replay, or just take a break till the next slide if you're watching live. Okay, NVO equals non-visual object, and it is pretty much exactly what it says it is. It's a PowerBuilder object with events and functions, but it's not something visual you can drop on a window. Instead, you declare it as a local, instance, or even global variable in script. You can create one from the main menu, doing File, New, PowerBuilder Object, PB Object, and Custom Class. You can also inherit from another NVO, so you may want to set up a base class and inherit from that. So how they're used depends on the auto instantiate property. So you have standard, and auto-instantiate non-visual objects. If the property is true, then it's an auto-instantiated NVO, and if it's false, then it's a standard. So standard NVOs must be created and destroyed manually, whereas auto-instantiated ones, you just scope them and use them. You call the functions directly without using the create. You cannot destroy auto-instantiated NVOs. The PowerBuilder garbage collect will clean them up. So I tend to use standard NVOs about 90% of the time. I like to control when they're created and destroyed. But in some cases, auto-instantiated makes the most sense. NVOs are considered portable, reusable, and plug and play. They're the best way to make use of the same logic in multiple places in your application, or even multiple applications. Code it once, plug it in where needed, and you're good to go. This also makes maintenance much faster and more reliable, since the code is in one place instead of all over the application. It also helps you partition your application. If you consider the model view controller pattern, where the database is the model and your windows are the view, NVOs will fall under the controller, and that's where you want your business logic. You want to avoid having business logic in your view. It will also allow a much easier and smoother transition if you ever decide to move to 3-tier application. It's almost the same with presentation tier, business tier, and data tier. Encapsulate functionality. You're building something that performs some type of service. You don't want it to rely on getting information from other objects. You want to pass all of the info that the service needs to the service and have it return whatever is needed. Business logic in one place. So we've kind of been over this a little bit, but I'll just give you a couple of examples. Consider a finance application where you may be doing loan calculations in many places. You would create an NVO with various loan functions in it. You may have a function to calculate loan payments and pass in loan amount, term, and interest rate. So let's say this is working great, and then a few years down the road, the government, in its infinite wisdom, decides to change regulations, and that affects your calculation. So you'd be much happier changing it in one place rather than having to search through your application for everywhere you duplicated your code. Another great example of this that I use all the time is encapsulating web service functionality in a service object. So I've done this pretty much with every web service I've consumed in the last about 10 plus years. And again, anytime there is a change in the web service from the provider, you just make your changes in your NVO. Some good examples of this in Code Exchange from my Dropbox API session 2020. That's also on YouTube. So if you wanted to search for PowerBuilder and Dropbox, you should be able to find that. I also did another session for Elevate 2021 this year on Google Maps Places API. So both have NVOs that can be used right out of the wrapper as they sit in Code Exchange, and you would just adapt those to your own application. Okay, NVO best practices. I'm going to only go over a few here. We could probably do a whole session on NVO best practices, but here's some of the top ones. The first one is a huge pet peeve of mine. Absolutely no message boxes in your NVOs. So you just don't want to add a visual component to a non-visual object. Now, if you want to do something like a sheet manager where you pass references to windows or things like that, there's nothing wrong with that. But don't have a message box, something that requires a response in your non-visual object. So many times you'll write an object thinking it's just going to be part of an online application, and somebody will try to reuse it, or you may try to reuse it yourself and put it in a batch app, forgetting that you have a message box in it, and that'll absolutely hang a batch app. It's happened to me probably 3 or 4 times where I've been on a contract and I've been asked to look at a batch app, and I'll go through the code and find message boxes in there, and I'll say, well, chances are you're being hung by this message box. And one time the developer who actually wrote the batch app said, oh no, there's no way that condition is being hit. I said, well, next time it hangs, let's plug in a monitor on the server and see what's going on. And sure enough, next time it hung, we plugged in a monitor, and there's a message box sitting there. So not something you want to do. Now, caveat here for this particular demo, it's important that I show certain things at certain times in the code. So I've added some message boxes. So I would never do that in an actual application or a non-visual that I'm writing for an application. So keep in mind that this is absolutely just for the demo, and don't put message boxes in your NVOs. Most important best practice is to use try, catch, and finally. So obviously you want to catch any runtime errors that occur in your non-visual object, and then that's the try catch. With the finally, it's perfect for any time you create anything like a data store or another non-visual object. Pretty much anything you create, you can destroy in the finally, because it's guaranteed to happen. So you'll never have any memory leaks from that particular code. Next super important thing is to validate your arguments that are passed to functions. So if you have strings passed in, you want to check them for null, things like that. If you have objects being passed in, you want to use things like is null or is valid, and just make sure that the objects are in the proper state. Same thing with numbers. If a negative number is going to ruin your code or make it blow up, then you want to check that's greater than 0, things like that. So always validate the arguments that come in. Another thing that I like to do is pass an extra string variable as reference that you can use for error messages or even returning success, things like that. So I usually will return integer or long for a return code, and then also have a return string that I've passed by reference. Another thing we'll show you in the code, I like to, again, it's just something I like to do, is use a constant for the function name, so that when you are returning, if you get an error or even on a success, you can return the name of the function, and it can't change because you've made it a constant. And another super important thing with non-visuals is, in addition to returning error codes and messages, you want to log those errors. So in the demo, I'll show you a simple version of that. Okay, now it's time for the demo. Okay, so we have a very simple application here. It's got 5 objects. Simple application object that just opens this wtest. We've got a data window here that you see to the right. It's just 2 columns, external source data window. If you've seen my Google Places API session, it may look familiar. It's one of the data windows I use in that demonstration. So it's basically from the Google API, it does a web service retrieval and it returns JSON, and then I display the JSON in the data window. So what I did was I just saved the JSON that was returned, so we basically skipped the call to the web service and we just populated the JSON. We have our Bulletproof object that we'll go over. It's just got 2 functions in it. It's got OF process and OF process Bulletproof. And you'll see it takes 2 arguments by reference, the data window, so we can copy the rows over once we get the data into the data store, and then a string, an error string. All right. We also have our log object, super simple. 1 function, OF log, pass it a string, gets today's date, opens the file. We'll write the error plus on the front of it, the date and time. Writes it out, closes the file. That's it. It's very simple. when you do your own log object, you probably want to make it a little more complicated. W test right here, very simple. It's got a data window and 2 buttons. First button, just a regular test, runs the OF process, and the second one runs the OF process Bulletproof. Since this is the only window in the application, I create the global log object on the open. Let's see here, and this is just something I like to do, especially on the open of a window. If you're creating something, I usually do if it's valid. If not as valid, then create it, because I've seen some crazy things in my years coding. I've seen people. So somebody may take this over and add to it eventually, not yourself, and they may trigger the open event again. Maybe want to refresh everything, and they think that calling the open event is a good way to do that. So as crazy as it sounds, I've seen it. So it's just a good practice that I like to do, the if it's not valid first. But you can I could have gotten away with just doing the create. And then on the cleanup, the close event, I clean up everything. I clean up the I clean up the global logging object, and then I'll show you I have this service is an instance variable. So if that's valid, I destroy that as well. Here we show the end Bulletproof and call it INV service. And now we'll get into the buttons. So simple here. Again, for the service, so I could have taken this instance variable and created it on the open event, and that would have been fine. But what I like to do especially if you're doing a service on a window, if you're doing other things on the window, your service may not even get called. So what I like to do is just create it when it's needed, and then the good way to do that is to check if it's already created, if it's valid, and if not, you create it, and then it's just simple. We run our OF process. We showed you this is the regular button, and then if there's an error here, we'll show a message box, but we're going to make it blow up, so we're never going to get to this. And I'll show you the Bulletproof button. It's the exact same code, and we're just calling OF process Bulletproof instead. And it's a good thing we did this here, because this is the second time, depending on which button we click first, the service is already created. So if we didn't have this if not as valid, it would try to create it again and cause an error. All right, so let's run it and see how it goes. All right, so first thing we'll do is we'll run just the OF process. And again, like I said, you'll see in the code when we do the code review, all we're reviewing in the code review is the 2 functions, the OF process and the OF process Bulletproof. The OF process just creates a data store, and then it doesn't import JSON with some JSON that I already had saved. I just have that as a string, and I do import JSON, and it goes into a data store. And then to make it blow up, I do a get item string on that data store. It's got 1 row in it, and I do a get item string for the 5th row and one of the actual columns. So that causes our friendly invalid row column and causes the application termination. You used to call it GPF, but it closes the whole app, kicks you right out, and you get nothing out of it. So let's see, we got here, boom, application terminated. We've got our invalid data window row column specified, and that's it. It's going to kick us right out, and we're gone. Now we'll run it again, and we'll hit the Bulletproof. Now, before I do this, I mentioned before that there's message boxes in the non-visual. We don't ever want to do that for real, but in order to show timing and things that are actually getting executed, it's just for show. We've got message boxes in the NVO. So here we go. All right, so instead of blowing up, we've caught the error here, and say we're in the catch. And again, we'll go through this in the code review, but we say runtime error has been caught, and now we're in the finally block. So finally block being executed, and here we go. Data store being destroyed in the finally block. And you'll notice also that the data has populated here. If I move this, so in the finally, I do the rows copy just because I wanted to show that it actually gets executed even though there was a runtime error. We've already got data in the data store, and boom, we copied it over. So we're just showing that the finally block is executed, and that code gets executed even though we caught a runtime error that would have blown up the application. And so now we're back in the window. In the button, remember, if the return was less than 0, we popped up a message box. So, and one of the things we'll go over in the code as well, OF process bulletproof, that's the name of the function. So that's back when I said that you want to use a constant for the function name. That's why I do that. And then when I catch the error and I want to populate it in the error string, I use the function name and then the error. So then we know, and it's really effective if you have, especially if you have multiple non-visuals, one calling another. You could have, I could also add the class name of the non-visual to that if I wanted. But anyway, you will know exactly which function caused the error instead of just returning the error and not being sure where it happened. So, and we say runtime error, and then here's what we caught. And again, there's our data. So let's go to the code review. All right, let's take a look at the code. So we're going to show the two functions that are in the NBulletproof object. The first one we'll go over is the OF process bulletproof. This is the good one that has the try catch and some other good stuff. So you don't see the arguments here, but we're passing the data window by reference, and also the string I was talking about before that you can use, put errors in, and pass that by reference as well. So the data window we're passing by reference so that we can do a rows copy later and to populate the data in the data window. So the data store, like I mentioned, our constant function name, OF process bulletproof. I like to, again, keep it as a constant, so in case anybody edits your code later on, a lot of people like to reuse string variables. They obviously can't use this one since it's a constant, so it'll never change. All right, we start our try block with our string JSON, and this was basically what I retrieved from the web service in the other session. So I could have created the JSON builder and made this fancy, but keep it as simple as possible. We have our JSON here. We wrap it in brackets so that it can be put into a data window with an import JSON. We create our data store, set the data object, and then we do our import JSON. Now, as you can see from the JSON itself, there's only one row with each of the attributes, name and place ID. So we get one row in the data store, and here's where we make it fail. So we do get item string, and there's only one row, but we're gonna take row 5 and the wrong column name. We're saying name 2, so it's gonna fail on both counts. And then we return 1. Here's the rest of the function. Here's where we catch runtime error. That's the highest level exception. If you search on runtime error, you'll see some of the other ones you can catch, but this is the highest level one, so it catches everything. And again, I made a note here just that this is just for a demonstration. We'll put a message box here. You don't really ever want to do that. But anyways, we're going to just for demonstration purposes, we did a message box. We've mentioned that we're in the catch, and we're saying that we caught a runtime error. And then, as you always want to do, this is the string that we passed in by reference as error, and we populate it with the function name plus runtime error, and then we do the runtime object.getMessage for the actual error itself. And then we log it with the global logging object, and we'll return -1. Now this is where it normally ends, except we have a finally. So the finally block will get executed at the very end, and you saw in the demonstration where we had a message box, so we hit the finally and it said finally block being executed. Then we do some cleanup. First we check, make sure that the data store is valid, and if it is, then we're going to check the row count. So again, we don't want to cause any errors, so we always check, make sure there's a row count before we try to copy a row. So we do rows copy here into the data window that we passed, which is ADW data. And there we go. And then we put a message box here saying we're going to destroy the data window, or the data store, I'm sorry. And that we're in the finally block and we're destroying it. And then we actually do destroy it. And then we end our try, and that's it. So that's what it looks like when it's bulletproof. And we saw with all the message boxes and everything, each part that we hit. And if you have any questions on that, feel free to bring it up at the end. And now we'll go into the regular OF process without the try catch and all the fancy stuff to keep it bulletproof. All right, so you notice we commented out the try, and all the other code is exactly the same. We set up the JSON string, create our data store, set the data object, do the import, and if we went through debugger, you'd see that it does return 1, so there's actually a row in the data store. And then we do our get item string, and it obviously fails. And you saw that it causes a runtime error that's not caught, so you get the application execution ended, and you get thrown out. So again, we commented out the catch and all the code in the catch and the finally. And so if this without the try catch, after we do the get item string, it would have done the data store, check the data store valid, check the row count, and done the rows copy, but it never reaches this because it had blown up earlier. So you never get to any of these other message boxes. The data store never gets destroyed, so you get a little memory leak there. And that's it. Time for question and answer.